All right, here we're looking at section 7.2, and our essential question is, what are the properties of parallelograms? So here's where we're really looking. So first, let's see our learning targets. Our learning targets are use properties to find the side lengths and angles of parallelograms. And then our second one is to use parallelograms in the coordinate plane. So the first thing we have to figure out, what is a parallelogram? And you will see this definition on page 368. So a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So I would know that this is an opposite sides, right? And then I would know that these opposite sides are parallel. And those are denoted by these arrows. The arrows do not mean that they're the same length. They just mean that they are parallel. So now let's look at our different theorems, okay? So my parallelogram opposite sides theorem. So if I'm talking about a parallelogram, then I know my opposite sides are congruent. So if this is a parallelogram, then PQ is congruent to RS, right? So my opposite sides, and QR is equal to PS, my opposite sides. So I know that if my sides are equal, I also know my angles would be equal then too. That's why these two theorems go very well together. So if this is a parallelogram, I know that my opposite angles, so Q and S, are congruent, and my opposite angles, P and R, are congruent. So that's only if that these are for sure parallelograms. So now let's go ahead and use these. So here's our first example. We're going to be finding the values of X and Y. So if you want to see a proof of these two theorems, look on page 368 and you can see the proof of them. But we're going to skip that for this video and just go into our example. So here's example 1. So find the values of X and Y. So let's start with X. Well, I'm told that this is a parallelogram by these arrows. So I see that these two only have one arrow and these two opposite sides have two. So I know that my sides, that we're talking about a parallelogram. And with my theorem, I know that my two sides, opposite sides, are equal. So I know that 12 is equal to X plus 4, because those are my opposite sides. So to solve for X, I can just subtract 4. So I know that X equals 8. So there's that solved already. So now I have to find Y. And based on my second theorem here, my opposite angles theorem, I know that these angles are opposite, so they're also going to be equal. So I know that 65 is equal to Y. So there we go. I've solved for both X and Y. So I know that I'm correct. So here is your first monitoring progress. So see what you can do with these and see if you can get those right. So now here's our next set of theorems. So the parallelogram consecutive angles theorem, right? And consecutive means next to each other. So if this is a parallelogram, then its consecutive angles are supplementary, right? So the angles next to each other. So like this angle and this angle. So if I add them together, I will get 180, right? And remember back, because supplementary means I can add them to equal 180. I also know that I could add Q and R to equal 180, since I know R and P are the same thing. Okay, so that's what my parallelogram consecutive angles theorem means. And just remember, consecutive next to each other, angles, and I know that they equal 180. So now let's look at this next theorem, my parallelogram diagonals theorem. So if this quadrilateral is a parallelogram, then the diagonals bisect each other. Don't forget, bisect means cut in half, and exactly half. So if this is a parallelogram, I can take my diagonal, which would be QS, and it would be cut by the other diagonal, PR. So I can see that this is denoted by the two hash marks. That means those two are the same. And the single hash marks means QM is congruent to MS. So now let's look at this example to show this. So this is going to be example number 2, using our properties of parallelograms. So as shown, a part of the extending arm of a desk lamp is a parallelogram, and that's in red right here. The angles of the parallelogram change as the lamp is raised and lowered. Find the measure of angle BCD when the measure of angle ADC is 110. So I know that this angle right here is 110. And so when I'm given word problems like this, I always want to start by drawing my picture and labeling the things that I know. So here I can see that I'm trying to find BCD. So I'm looking for this angle right here. So I know that in order to find it, I see that I have consecutive angles. They're right next to each other, right? They're not across from each other, so I know that they're consecutive. And I know that consecutive angles equal, add up, sum to 180. So I can take that, and sorry, that's 110, and I say this is going to be x, so now I can set up my equation. I know that they add up to 180. I'm told that angle D is 110, and I'm trying to find angle C. So I can go ahead and I subtract 110 from both sides, and I know that angle C is going to be 70 degrees. So now let's look at this as example number 3. Write a 2-column proof. And I'm going to click on this one. So given that ABCD and GDEF are parallelograms, prove that angle B is congruent to angle F. So first thing I want to do is I want to draw my picture and label it. So I know ABCD is a parallelogram, right? So I know that these two are parallel and these two are also parallel. And then I know that GDEF is a parallelogram, so I'm going to label that as well. Right, and I like to use different colors, so now I'm going to write my 2-column proof to prove that angle B is congruent to angle F. So first, I always start with my givens, right? So I know that the first given is that my ABCD and GDEF are parallelograms, and I'm told that up here. So the next thing I can say is angle CDA is congruent to angle B, right? And I can't just say that this is angle D because there's 4 different angles that could be considered D, so I have to be specific. So let me draw what this one looks like. So angle CDA, right, is this one, is congruent to angle B. So, and I know that because if my quadrilateral is a parallelogram, then the opposite angles are congruent. I also know that angle EDG is congruent to angle F, right? That's my theorem as well, that if it is a quadrilateral, and if it is a parallelogram, then my opposite angles are congruent. So now I know that angle CDA and angle EDG are congruent, right? These two green in the middle. And I know that because they're vertical angles. Remember back when we did other angles, if I have 2 lines that cross, the angles on opposite sides are congruent because they're vertical angles. That's what this is showing right here too. So then if I know that those two are congruent, then I know that angle B is congruent to angle F based on my transitive property. Okay, so now I've gone ahead and I've proven these 2 things using my 2-column proof. And you will continue to use 2-column proofs, so keep in this habit of using your statements over here of what do you need to prove next, and then your reasons. This is the mathematical stuff that explains why we can do what we're doing. Okay, so here is some monitoring progress, so give these a try and see where you get. So here we're looking at example number 4. So here we're starting to use that second learning target is using these parallelograms in the coordinate plane. So I'm supposed to find the coordinates of the intersection of the diagonals of parallelogram, that's what this little symbol means, LMNO with vertices at 1, 4, 7, 4, 6, 0, and 0, 0. Okay, so here we now have our coordinate plane so we can draw our points. So point L was at 1, 4, and I'm just going to label which points are which. M was at 7, 4, 2, 3, 4, 5, 6, 7, 4. This one was M. N was at 6, 0. And O was at the origin. Okay, so here is my parallelogram drawn in my coordinate plane. Okay, and so I know that I have to find the intersection of the diagonals. Well, I know that if this is a parallelogram, which it is, then I know that where my diagonals cross cuts them in half. So here's kind of a general picture of where it looks like approximately. Okay, so I know that I need to find the midpoint, right? And the midpoint is where they cross of one of my diagonals. So I'm going to go ahead and use OM. I can use my other diagonal, my LN, but I like OM because point O is pretty simple. So I'm going to go back and use my midpoint formula, right? So the points that I'm using are 7, 4 and 0, 0. So I know I'm going to use my midpoint formula. So 7 plus 0 divided by 2. 4 plus 0 divided by 2, right? So here's my x1s, here's my y's, and then I divide by 2 because I find the midpoint. So my midpoint, or where they meet, is going to be 7/2, comma 2. And I can go ahead and leave it simplified this way. And so I'm just going to double check by looking at my graph. So I know that 7/2 is the same thing as 3.5. So let's see if I'm close. So 1, 2, 3.5, and 2. Yeah, that looks about right with how I've drawn this on my example. But I always want to go ahead and do the math and not base it just on my hand-drawn picture. So now here is going to be example number 5. So I know 3 vertices of this parallelogram W, X, Y, Z are at -1 and -3. We're going to go ahead and draw them as we go. -3, 2, and 4, -4. Okay, so here we are. Those are 3 points. So I'm supposed to find the coordinates of vertex Y. So I'm missing 1 point. And I know, right, just based on this shape, that it's going to be up here somewhere. Okay, it's going to be somewhere in here. So first thing I want to do, and I'm going to actually go back and label these. This was W, and this was X, and this is Z. So I know that for this to be a parallelogram, my sides have to be parallel. And in order to have parallel sides, I know I'm going to have to find the slope. So let's find the slope from W to X first. So I see that from X, and I know that slope is rise over run. So I go up 1, 2, 3, 4, 5, and I go over 1, 2. And I know that this is a negative slope because as I go from left to right, it's a negative. So my slope is a -5/2. So that tells me that my slope from point Z to point Y also has to be a -5/2. So I know that I can go up 5 and then back to the left 2 from this point. So 1, 2, 3, 4, 5, 1, 2. So this is going to be where my point Y lies. Okay, and I know that I go up and back because to get from X to W I went up and back. So I just found my slope. So now I know that my slope between YZ and WX is the same. So I know that this is a parallelogram. So now I can find my slopes of XZ and WY just to confirm that I'm correct, right? Because we always want to double check. So I know that my slope from XZ is I go down 1, and I'm just going to label that this is my slope for XZ. So I go down 1 and I go over 1, 2, 3, 4, 5. So there was my slope right there. So now let's look at the slope of WY. Okay, so this right here. So I see I go down 1 and I go over 1, 2, 3, 4, 5. So these two slopes are the same thing. So I know that I am correct in where I found point Y to be. So here's some more monitoring progress, just using the coordinate plane. So try these. It's very important to know how to use these in the coordinate plane and not just look at distances and lengths. So now let's look back at our learning targets. So use properties to find the side lengths and angles of parallelograms. And remember, those properties are those theorems that we talked about, knowing that the opposite sides are congruent and the opposite angles are congruent, and that those angles next to each other sum or add to 180. And then my second learning target was using parallelograms in the coordinate plane. So that was back here when we're using actual coordinate points, and we first have to draw what we're looking at. It's really difficult to see these things without actually drawing them out first. So now that we've gone through these and we know these learning targets for sure, now it's time for you to go ahead and start working on that homework for this section.